This is 3.2, doing chain rule with trigonometry. Doing chain rule with trig can be a little bit tricky because it can be tough to figure out what's the outer and the inner. Most of the time, the trig is the outer because you've got trig, like sine or cosine, of something in parentheses. But every now and then, the trig is the inner, and we'll do an example or two that looks like that. So, for the first example, f of x equals sine of 2x. The outer is sine of something, and the inner is what's inside the parentheses. So the derivative of sine is cosine of something, and the derivative of cosine, of 2x is 2. So then we're going to say f prime of x is derivative of the outer, cosine of something. That something is the inner, 2x times 2. And then because we usually write this least complicated to most complicated, we're going to write it as 2 cosine of 2x. And we do that for a couple of reasons. If we leave the 2 on the back, the times 2, it's tough to tell whether we mean the cosine of 4x or whether we mean 2 cosine of 2x. And what we mean is 2 cosine of 2x. So it's more helpful to put the 2 out front. For the next example, very similar. It's cosine of 5x squared. So when you read it and you say that word of, it usually tells you that the cosine or the trig is the outer. So we're going to say cosine of parentheses. The inner then is 5x squared. The derivative of the outer is negative sine. Don't forget that negative. And then the derivative of the inner, we're going to do 5 times 2 and get 10 and reduce our exponent by 1. So then I'm going to say g prime of x is the derivative of the outer, so negative sine of something. That something is 5x squared times the derivative of the inner. And again, to avoid any confusion, we're going to take that 10x and we're going to put it up front because we mean 10x times the sine of 5x squared. We don't mean 5x squared times 10. In the next example, we have a square root, and we don't keep square roots, so I'm going to write this as the sine of x raised to the 1/2 power. And this time, the sine of x is the thing inside the parentheses. So the outer is something to the 1/2 power, and the inner is the trig. So the derivative of the outer is 1/2 parenthesis to the negative 1/2, because 1/2 minus 1 is negative 1/2. And then the derivative of sine is cosine. So we're going to say dy dx, because that's what the instructions told us to do, find dy dx. And we're going to say 1/2 parenthesis to the negative 1/2. And we're going to say that sine of x goes in the inner, and we're going to multiply by cosine of x. We have a negative exponent and we have a fraction that we're dealing with. So the negative exponent and the thing that has the negative exponent, the sine of x, are going to the bottom. Cosine stays in the top. So we're going to have cosine of x over 2 sine of x quantity 1/2 power. For the next one, we're back to cosine of some stuff in parentheses. So cosine of parentheses is going to be the outer. The inner is going to be the x squared minus 3x. The derivative of cosine is negative sine of parentheses. And the derivative of the inner is going to be 2x minus 3. Let me write this one over here because I didn't leave myself a whole lot of room. So we're finding the derivative, so I'm going to say dy dx. And we could say y prime here because it didn't specify, but we'll go ahead and say dy dx just to get some practice. And we're going to do negative sine of parentheses. In the parentheses, we're going to put x squared minus 3x times, and then in parentheses, we're going to put 2x minus 3 because that came as a quantity. And then to clean things up, make things less ambiguous, we're going to move that 2x minus 3 to the front and put the sign of x squared minus 3x second. For the next example, we've actually got trig composed of trig. So we've got cosine of sine of x. Notice there are not two x's here. There's only the one x. So this is composition. It's not product rule. So I'll make a little note here, not product, just so that we know when we look back on this. So the outer function is the cosine. The inner function, because it's in the parentheses, is the sine of x. Derivative of cosine is negative sine of parentheses, and the derivative of sine is cosine. So it says find f prime, so we're going to say f prime of x equals, we'll start with the derivative of the outer, so negative sine of, in the parentheses, we're going to put sine of x, because that's the inner, and then times cosine of x. Now this one is a bit strange to write just because it's tough to make it not ambiguous, so it's okay to write it the way we have it. It's also okay to write the cosine of x up front, but I would put it in parentheses. I would write it like this, just to make sure we're not confusing what's in the cosine, what's outside the cosine. For the next example, we have a 3x squared out front, and that's getting added. That's a regular old constant multiple rule. The chain rule is the sign of the stuff in parentheses. So we're going to have sine of some stuff in parentheses. The derivative of that is going to be cosine of parentheses. The inner is the stuff in the parentheses, so 3x squared minus 2x plus 1. And the derivative is 6x minus 2. So when we take the derivative, and we'll go ahead and use y prime this time, because we can, we're going to take the derivative of the 3x squared first and get 6x. Then we're going to have plus, and then we're going to do our chain rule. So we're going to say cosine of 3x squared minus 2x plus 1 times, and then in parentheses, because it comes as a quantity, 6x minus 2. So I can write this as 6x plus, I'm going to put the 6x minus 2 out front, and then cosine of 3x squared minus 2x plus 1. So I treated them almost as if they were two different problems and then merged them when I finally put the end together. And then sometimes we can have multiple layers. So with this first example, I have sine of some stuff. So sine is the outer, cosine is derivative of the outer, then the inner is 4x plus 7 to the third power. Well, to get the derivative of the inner, I have to do a whole other set of outer, daughter, inner, and dinner. Because the outer is something cubed, so the derivative of the outer is 3 something squared, and the inner is 4x plus 7, so the derivative of the inner is 4. So when I put that derivative together, I'm going to say 3 something squared. That something is 4x plus 7, and I'm going to multiply that before. And then I'm going to do 3 times 4, so that's going to get me 12 times the 4x plus 7 squared. And that's going to be the derivative of the inner. So when I finally put all that together, we called the function f, so the derivative is going to be f prime of x. I'm going to have cosine of the inner, which is 4x plus 7 to the third, times derivative of the inner, which is 12 times 4x plus 7 to the second. So when I finally clean this up, I'm bringing the 12 and the 4x plus 7 squared to the front because it's less complicated. And then cosine of 4x plus 7 to the third comes after that. The next one is similar. We have a square root, so we have to do a little rewrite. I have to write this as cosine of x squared plus 1, and that all gets raised to the 1/2 power. So the outer is something to the 1/2. The inner is cosine of x squared plus 1. So the derivative of the outer is 1/2 parenthesis to the negative 1/2. Derivative of the inner requires its own set of outer, doubter, inner, and dinner. The outer of cosine of x squared plus 1 is cosine of something. The derivative of the outer is negative sine of something. The inner is x squared plus 1. And the derivative of the inner is 2x. So when I put that all together, I get negative sine of x squared plus 1 times 2x. When I simplify that, I get negative 2x sine of x squared plus 1. So I put that all together. Our function was called g, so my answer is going to be g prime of x. I'm going to start with the derivative of the outer, so 1/2 parentheses to the negative 1/2. The inner is cosine of x squared plus 1 times derivative of the inner, which is negative 2x sine of x squared plus 1. And when they start to get this nasty looking, I'm okay with you leaving it like that, but let's go ahead and fix the negative exponent. So that means if I look at this very closely, I've got a lot of multiplication going on. I've got a 1/2 times a negative 2. So those are going to cancel out. So I'm just going to be left with negative x sine of x squared plus 1. And then over cosine of x squared plus 1 to the negative 1/2. Whoops, I'm sorry. I was worried about the parenthesis. It will be a positive 1/2 because we moved it to the bottom. And then for the last one, a real brain stretcher, we actually have two x's. And so you say to yourself, what are those two x's doing? Are they adding, subtracting, multiplying, or dividing? Well, the cosine of x is multiplying by the stuff that has the other x. So I've got cosine of x times this composition with an x in it. So I'm going to start with product. So I'll say start with product. So here's my box. And I'm going to say cosine of x and then sine of cosine of x. The derivative of cosine of x is negative sine of x. To do the derivative of sine of cosine of x, I need chain rule. So I'll work that over here. The outer is sine of something. So the derivative of the outer is cosine. The inner is the cosine of x. And so the derivative of the inner is negative sine of x. So putting that together, I'm going to have cosine of something. That something is going to be cosine of x times negative sine of x, which I'm actually going to write as negative sine of x. I'm going to pull that to the front because it's less complicated than cosine of x, which is not cosine squared, as it were. So negative sine of x times cosine of x goes up there. And the instructions said find dy dx. So I'm going to say dy dx. And I'm going to do my product rule box. So I'll start in the lower left-hand corner. And I will say negative sine of x times sine of cosine of x plus, then I'll do the other diagonal, and that'll include my chain rule. So I've got a negative sign, so let's go ahead and just make that plus a negative. And I'm going to have cosine of x times sine of x of cosine of x. And that's as simplified as that's going to get. Technically, they both have a sine of x. I could factor that out. I could factor out a negative sign. So if you wanted to, like where I left it is perfectly fine. I'll highlight it in green as a perfectly fine way to leave your problem. But if you wanted to simplify it for more, I could take out a negative sine of x and be left with sine of cosine of x plus cosine of x times cosine of x, which is gross in and of itself.